Hello everyone, let's look into cubes, which is another very common and very important topic, and sometimes the questions related to cubes can also appear in quant section. So this is very important for quants also. So let us quickly understand the basic information or the terminology related to cubes, and we'll also learn about cutting of cubes in this video. So the basic structure of a cube has three components: faces, edges and the corners or vertices. So let us start with corners or vertices of a cube. So there are 8 vertices or corners in a cube. The ones encircled with the red color, these are the 8 vertices or corners of a cube. Now moving ahead, we have got faces. So there are 6 faces in a cube, and those 6 faces are the front one, the rear one, the face at the top, the face at the bottom, the face at the left and the face at the right. So there are 6 faces in a cube, and all these faces are square faces and all the faces are identical. Now coming to edges, an edge is formed when two faces of a cube coincide. So this is one face, this is one face. When these two coincide, this is the edge that is formed. Similarly, this is an edge, then this is an edge, then this is an edge. So likewise, a cube has got 12 edges, which can be represented by these red zigzag lines. So I hope the basic structure of a cube is clear to you. Now let us see what sort of questions are asked and the concepts used behind those questions. So most of the questions related to cubes will be based upon cube cutting. That means we have to cut a cube into smaller pieces. Then there will be questions upon how many cuts should we make, how many cubes will be formed by a certain number of cuts, and so on. So there are a few assumptions that we have to take care of while cutting a cube. The first assumption is all cuts are complete. That means whenever we'll cut a cube, that cut must divide the cube into 2 or more pieces. There won't be a case that we are only half cutting a cube till here. The cut must always be a complete cut. It should divide the cube into some pieces. Now the next assumption is all cuts are made and then the cube is opened, which means that if it is given in a question that a cube has to be divided making 5 cuts, then first of all those cuts will be made and then only the cube will be opened or scattered. So first of all the cuts will be made and then only the cube will be opened. Then the next assumption is no slant cuts. The cuts would be parallel to 2 parallel opposite faces and perpendicular to the remaining, which means that we don't have to make any slant cut like this or this. Whatever cut is made, it must be parallel to the 2 opposite faces and perpendicular to the remaining. Let us see how. So if this is the cut made, then this cut is parallel to this face and the face opposite to it, which is this face, and it will be perpendicular to the remaining 4 faces, this face, this face, this particular face and this particular face. I hope the assumptions are clear to you. Now let us look into cutting a cube and find out the number of pieces obtained by making those cuts. So let us do this with an example. So if we have a cube and if we make only one cut, so it is very obvious that a single cut will divide a cube into 2 sections or 2 pieces, this piece and this piece. So we can say that one cut leads to 2 pieces. We are not talking about the number of cubes or cuboids formed. We are just considering the number of pieces obtained by cutting a cube. Now let us try to make 2 cuts. So 2 cuts can either be made like this, which gives us 1, 2, 3 pieces in this case, or we can make 2 cuts like this and this. So we have 2 cuts here also, but in this case the number of pieces formed is 4, 1 piece, third piece and fourth piece. So in this case 2 cuts lead to 4 pieces and here it was 3. Now let us try to consider 3 cuts. So 3 cuts can either be made like this, which will give us 4 pieces in this case. Now what if we have to make 2 cuts like this and 1 cut like this? So in this case we have 1, 2, 3, 4, 5, 6 pieces. So making cuts little bit different from the first case gives us 6 pieces. Now what if we have to make 3 cuts like this and like this? So we have made a cut along the length, then 1 cut along the breadth and 1 cut along the height. So in this case we can clearly see that we can get 1, 2, 3, 4, 5, 6, 7 and one more cube which is not visible in this case. So we'll get total 8 pieces by making 3 cuts in this way. Now one thing that you should keep in mind while solving questions based on cubes is that you should have a good visualization of the situation that we have been given, because for each different situation you have to visualize differently. You should be able to picturize the situation in your mind, that how are the cuts being made and how is the cube being divided. So from these cases what we can see is that for the same number of cuts we can have different number of pieces obtained. So we'll be using this concept while minimizing and maximizing the number of pieces obtained after cutting a cube. So it is very important to understand this concept to tackle the questions related to maximizing and minimizing the number of pieces in a cube. Let us move ahead and consider a few more cases. What if we have a one-dimensional figure like a line segment? So what will be the number of pieces obtained by cutting a line segment into several pieces? So if you give 1 cut to a line segment, then it will give us 2 pieces. If you make 2 cuts, then we get 3 pieces. If we make 3 cuts, then we get 4 pieces. So similarly for n cuts, we get n plus 1 pieces from a line segment or a one-dimensional figure. Now what if we do the same with a 2-dimensional figure? So if we make all the cuts in the same dimension, like 3 cuts here, then it will definitely give us 4 parts or 4 pieces. But suppose if we make 3 cuts along the length and 2 cuts along the breadth, then we get total 12 pieces by making such cuts. So 3 cuts along the length and 2 cuts along the breadth, or total 5 cuts, gives us 12 pieces. So if we consider the length as the x-axis and the breadth as the y-axis, so making 3 cuts along the length gave us 4 pieces, which means x plus 1 pieces, and making 2 cuts along the breadth gave us 3 pieces, so we can write it as y plus 1, where x is the number of cuts along the length and y is the number of cuts along the breadth. So the total number of pieces obtained would be x plus 1 into y plus 1. So in the case given, we made 3 cuts along the length and 2 cuts along the breadth, which gave us total 4 into 3, which means 12 total pieces. Now we can easily extend this result into cubes, because in cubes we just have one more dimension, which is the height. So in a cube, if we are making x cuts along the length, y cuts along the breadth, and z cuts along the height, then the total number of pieces by making such cuts would be x plus 1 into y plus 1 into z plus 1. So this is for cubes. So this is a very important result that you have to remember. Now let us consider the concept of minimizing and maximizing the number of pieces obtained by a fixed number of cuts that we learned in the previous slide. Like if you have been given 5 cuts, then how those cuts should be made so that you can generate maximum or minimum number of pieces. So we'll learn minimizing and maximizing number of cubes with number of cuts. So let us assume a case where we can make only 6 cuts. Now since we have a cube, we'll be having x-axis, y-axis and z-axis and the number of pieces in these axes. So if we have to make 6 cuts, and if we make all the cuts in the x-axis and no cuts in the remaining axis, then the number of pieces obtained will be 7 pieces in x-axis, 1 piece in the y-axis and 1 piece in the z-axis. So the total number of pieces obtained after making such cuts would be 7 into 1 into 1, which will be 7 pieces. Similarly, if we make 5 cuts along the x-axis, 1 cut along the y-axis and 0 cuts along the z-axis, then the number of pieces obtained respectively would be 6, 2 and 1, which will give us the total number of pieces obtained as 6 into 2 into 1, that means 12 pieces. Similarly, if we make 4 cuts along the x-axis, 1 cut along the y-axis and 1 along the z-axis, then the number of pieces obtained would be 5 pieces along the x-axis, 2 pieces along the y-axis and 2 pieces along the z-axis, which will give the total number of pieces obtained as 5 into 2 into 2, that means 20 pieces. Similarly, 3 cuts here, 2 cuts here and 1 cuts here would give us 4 pieces, 3 pieces and 2 pieces, that means 24 total pieces. Similarly, if we give 2 cuts here, 2 cuts here and 2 here, then the number of pieces obtained would be 3, 3, 3. So the total number of cubes obtained here would be 27 cubes. So if we notice this case, then we can see that we have divided these 6 cuts provided equally into x-axis, y-axis and z-axis, and in this case we are getting the maximum number of cubes. So we can say that to maximize the number of cubes or the number of pieces, we have to distribute the number of cuts equally into all the axes. So for maximizing the number of cubes after cutting, we have to evenly distribute all the cuts into the axis. And the minimum number of pieces obtained is here, which is 7. So for minimizing the number of pieces obtained, what we need to do is we simply need to concentrate all the cuts into a single axis. So I hope the concept of minimizing and maximizing the number of cubes with cuts is clear to you. Let's solve some questions